Okay, so first lesson, pre-calc B. There will not be what I call a pre-lesson. This is just straightforward, so I think we can just dive right in and make sense of this without a pre-lesson. So let's just start. Domain, you need to understand, has to do with your x values. Range has to do with your y values. Now, good memory tool, what comes first in the alphabet, D or R? Well, D does. What comes first in the alphabet, X or Y? X does. So that's a nice little memory tool. Domain is always referring to your X values. Range is always referring to your Y values. Now let's look at this XY axis. What is my domain? My domain is how far to the left does my equation or graph go, and how far to the right does it go. My range refers to my y. So when you see the word, hey, what's your range? You're wondering how low does my graph go and how high does my graph go. Now, that's kind of the lesson in a nutshell. This little symbolism right here, we'll talk about it as we go. I'll refer back to this in a minute. But there's a really strange little rule here. It says the graph of any function will pass the vertical line test. But that word function takes us back to this and says a function from the set D, what's that? Domain, what's that? All your x's, to a set R, what's that? Range, what's that? All your y's, is a rule. So that's what this is. It's a rule. In other words, a function is defined by a rule that says every element in D, so all of my x's, will produce a unique, what's that mean? Different element in my range, which is my y's. So the easiest thing I can think of is like a line. Y equals, I'll just say 2x plus 1. If I was to graph that, I'd go to my y-intercept 1, then I'd go up 2, right 1, and there's my graph. Now, why is that significant? Why can I refer to this as a function? Because if I was to make one of these little rascals, and I picked an infinite number of x's, even though I'm not going to, and I plugged them all in, like negative 3 times 2 is negative 6 plus 1 is negative 5, negative 2 times 2 is negative 4 plus 1 is negative 3, negative 1 times 2 is negative 2 plus 1 is negative 1. You can kind of see the pattern. And this would be a 1. And I mean, I could go on forever and ever. All these unique x's produce a unique y. In other words, I never see a duplicate y. Okay? That means this is a function. This vertical line test is just a quick way, instead of doing this every time, you just draw a vertical line anywhere you want in your graph, and you're like, oh, it only hits it in one spot. In other words, you got a unique y. I could have drawn it here or here or here. It's only going to hit that graph one time. So let's dive into these sample problems here. This is saying, hey, look at this graph. You don't need to know the equation. Just look at the graph. What's the domain? Well, those are my x's, which means how far to the left does it go and how far to the right does it go? You have to ignore the up and the down because that's my range. Well, how far to the left would this graph go? If it just, see that arrow means it just keeps going forever. This arrow means it keeps going to the right forever. So if I jumped on this graph and just went forever and ever and ever, how far to the left? See, I know your brain is thinking up, but that's not what we're concentrating on. We're concentrating on the domain. How far to the left, how wide would this thing eventually get? Well, you got negative infinity over here. Now, technically, they say, they disagree with Buzz Lightyear. Buzz says you can get to infinity and beyond, but they say you can't actually get there, so you signify it by using parentheses, negative infinity. Now, how far to the right, or how wide will this thing go if it just went on forever? Well, that would be infinity, and you would have to use parentheses on the end of that, meaning you would never reach it. So again, they disagree with Buzz Lightyear, to infinity and beyond. Let's talk about range, and that will help us understand this bracket terminology, which means the value can be included See, infinity, you can't get there. That's what this is saying. So that's why you have to use parentheses. A little confusing at first, but it will make sense. So my range is how low does it go, and then how high does it go. By the way, you always start with how low does it go. Well, if this is my y-axis, the negative, and this is my positive, how low does this go? Well, the lowest point is 0, and it does touch it. It's like greater than or equal to. That's what this is kind of symbolizing. But then how high does it go? Either direction, how high does it go? That would get to infinity. But again, can't reach it. Is it a function? Well, we give it the vertical line test. Anywhere you want. It only touches it in one spot. So we say, yep, that's a function by definition. Okay? All right, let's try this. Domain. Again, it's my x's. How far left does it go? How far right does it go? You always start with how far left. So if we look and we think, okay, it gets to -4, and it does include it. So it's a bracket, -4. How far to the right would this graph go? Well, this would go on forever. This would go on forever. And you got infinity sitting over here. Sorry about that terrible infinite. I'll make up for it right there. There. And it never touches it. Range. How low does it go? Well, if this just keeps going and going and going, it's going to go down to -infinity. And you always start with how low it goes. And then how high would it go? Well, it would take a while, but if it goes on forever, it's going to get up to infinity. Is it a function? Well, I draw my vertical line and see how it touches it in two places? That means nope, because my value for x will produce two different values for y, and that just means it is not a function because it breaks the definition of what a function is. So we say no. Domain on this one. How far left does it go? Well, how wide does this go if it goes this way forever? Well, that will be -infinity. Again, don't think down. I know the arrow is pointing down, but domain means your x's, which means how far to the left and how far to the right. Well, it would continue getting wide to the left forever. How far to the right would it go? Well, it would continue expanding like this way forever. So, positive infinity. Range. Again, you start with how low does it go? Well, both of these are going to go down forever. So it's -infinity. How high does it get? Well, it gets to here, it peaks, and then comes down. So what's the highest value? It goes up. 0. Does it include it? Yes. That means you need a bracket. Is it a function? Yeah. Anywhere I draw a vertical line in, I'm only going to touch it in one place, so I say yes. All right. Now they're going to get a little bit more specific by giving, well, they did. They said these are all parabolas. But now we've got a square root function. You don't have to worry about its name right now, but they're just kind of warming you up for a lesson that's coming. But this is a square root function. What's the domain? Well, how far left, what's the furthest left this goes? Well, right here. So that means it starts at 0. How far to the right does it go? Well, that'll go on forever and ever and ever. Range. How low does it go? Well, if we're talking about my y-axis, it gets down to 0. Whoops. And it touches 0. Almost made a little mistake there. And then how high does it go? Well, it's flat, but it does continue going up and 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 up forever. So eventually, it will reach infinity. And it doesn't ask if it's a function, but yes, it would be because it would just cross it once. All right, sine function. What's the domain? Well, from last trimester, you remember sine just kind of keeps going forever and ever and ever. And so it goes to the left forever, so that's -infinity. How far to the right does this go? Well, because that's an arrow, it's an indication that it never stops. So that would go to positive infinity. Range. How low does it go? You know what another word for this is? What's its amplitude? Well, it's 1, but it goes down 1 here. The little valleys get down to -1. And yes, it touches -1. So that's the low point. What's the high point? Well, that's the amplitude. Gets up to 1. So there's a couple of those little half a boxes, which means it includes -1 and +1. Okay, last problem. This one's interesting. This dotted line is called an asymptote. That means the graph does not cross. Mathematically, it is impossible to cross that. So, that would be something, I'm just making this up, that would be something like this. F of x equals this. Now, I'm not saying this is this graph. Don't get me wrong there. I'm just making this up. I'm just showing you. See, x can't be 2. X cannot be 2 because we'd get a 0 in our denominator, which is mathematically impossible. That's where these dotted lines come from. My point is, how far left does it go? Well, this graph goes closer and closer and closer and closer. It tries so hard to touch it, but it never can. It can get to 2.00001, but it cannot touch 2 because it's mathematically impossible. So, parentheses, 2. Now, how far right does it go? If it keeps going that way forever, it's going to get to infinity. Well, it's not technically going to get to infinity, but what's the range? Well, we start with how low it goes. See how it just keeps going down, 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 down? So negative infinity. How high does it go? Well, it starts screaming up forever because of the arrow. So that means infinity. Now, let's go back to this one. I'll throw this in for free. If they asked us if this is a function, we'd go, well, yeah, it's in the name, but let's test it. See, it touches it in one place. How about this one? One place. So we'd say yes. That's it, guys. Pretty straightforward lesson for your first lesson of the second trimester pre-calc. Good luck on your homework.